Okay, calculus classes. As promised, I'm going to give you the solutions for your day. I think it was 50. No, wait. I thought it was 52 homework. So I think there's 14 items. So I'll check it out. That is finding the antiderivatives. So I want you to grade that assignment. So let me, then what I'm going to do is finish up basically part 2 of this. It's really not a full part because I did almost everything. It's just that there's some things we could tweak, okay? And then you're going to have to do the homework and get that done, completed, okay? So let's see. Well, whatever, it's day 52, 53, whatever the homework is. I think those were the problems. You were doing some antiderivatives using the reverse of the power rule of the derivative. Pay attention to your plus C, okay? Pay attention to try to simplify your answers as best as you can. So you can pause it. I'm just going to move to the next slide, and then you can grade the rest. Kind of awkward just to sit here and look at these problems. Again, you can pause it and then hit play whenever you're ready to move on, because I'm moving. And last but not least, there might be an issue with this last one. I may have cut off. I didn't find C. It looks to me like that goes to 0, that goes to 0. C is 3. So you would represent your answer that f of x is 1/12 x to the 4th plus 6x plus 3. Let's go with, see, 14 items. 14 times 7 is 98 points. So yeah, let's just subtract 7 if you didn't do the whole problem. You decide how many points you take off from 1 to 7. And let's see who's paying attention. I want you to turn the homework into the sub. Okay? I want you to turn the homework into the sub so I can look at it. You have two choices. Okay? You can turn it into the sub, or you can take pictures of each piece and post it in its learning. But I want a PDF file. So you'd have to do that probably when you get home. But I want one PDF with your homework. Or turn the paper hard copy in and pick up the paper tomorrow. Your call. Let's move on. Decided to do another trapezoidal rule problem. And what we're doing with these trapezoids is we're creating vertical trapezoids that could look like this, or they could look like this. But if you put them in the normal way that we're used to looking at trapezoids, it would be this. The other one would be that way. We're just laying them differently, you know. And the height of your trapezoid is actually what we would call probably the width. because it's actually a width. It's like if I draw a trapezoid here, just randomly here, I draw a trapezoid. It's actually the width of like a rectangle would have been, and that'd have been the length. But in this case, if I call that length, and I call that's it doesn't, they don't have the same. In the normal picture, that's my height, that's my base 1, that's my base 2, that's my height, that's my base 1, that's my base 2. But really, I'm calling these bases, so length actually is a base. There's two different bases. So, with that being said, what does he want us to do? They want me to divide the area from 1 to 7, and we're subdividing the area bounded by the graph and the function and the x-axis into trapezoids of, wow, why does it sound like I did this one? I don't know, it seems like I did, but it doesn't hurt to do it again. So if I'm going from 1 to 6, and I want each division to be of 1, well, that would make sense. That would be one division, another division, another division, another division. Stop when you get bored. Another division. Right here. So I'm only going from here to here of trapezoids. And the rule was go for each of these pieces here, each of these, you're moving straight up to the function. Touch the function. Touch. 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 I feel like I'm playing duck, duck, goose, but the goose is right here. So each of those bases have to go up to the function, and the value of that function, of the x value that I'm at, whatever it is, will be a base, okay? And so if I look at the first division here, it's obviously, I'm going to make that the trapezoid. And as I go up the curve, that's the trapezoid. Now it's going to go down the curve. Trapezoid, 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 and a real long slant, trapezoid. So that's what's going on. So the magic is this. If I was to be critical, these are all separate bases. In other words, I will call this one base 1, base 1. I will call this one base 2. And the area of that trapezoid, see, this distance here is the same thing as your height. That height is 1. So my area of that trapezoid is 1/2 times the sum of the bases times the height, or you could put the height over the 2 sum of the bases. So in this particular problem, my height is 1, because that's the height right here, 1/2 of base 1 plus base 2. So that would be my first trapezoid. My second trapezoid, well, you got this base 2 here, is the left side, and I got base 3 here, is the right side. So that trapezoid area would again be the height divided by 2, which is 1/2, but this time it's the base 2 plus base 3. Then if you look carefully for your fourth trapezoid, the left side is already taken up with B3. The right side I'll call B4. So then that trapezoid, the third one, would be the 1/2 B3 plus B4. And then that's my 1, 2, this is my third trapezoid. 1, 2, 3. I did 3. So now I'm going to do my fourth one, realizing this is base 4. Wait, 1, 2, 3, 4. Base 5. That's my fourth trapezoid. 1, 2, 3, 4. So A4, the fourth trapezoid, is the 1/2, the height of that trapezoid, which is really the width at the bottom. It's the width of on the x-axis times the left side of B3. Wait, I did that one. Hold on. 1, 2, 3, 3, 4, B4, B5. B4 plus B5. And then I go to my next trapezoid, and that's my base 6. Base 6, so A5 is the 1/2 B5 plus B6. And then my seventh trapezoid. Why is there 7? Well, because I was dividing it by, you can tell by how many there's going to be. If I went from 1 to 7, think about it. From 1 to 7 means that 7 minus 1 is 6. That means there's going to be, that's 6 trapezoids. 1, 2, 3, 4, 5. What? I already have 6. B1, B2, B2, B3, B3, B4, B4, B5, B5, B6, B5, B6, B7. Oh, 7 is that particular base, B7. 1 trapezoid, 2 trapezoid, 3 trapezoid, 4 trapezoid, 5 trapezoid, 6 trapezoids. 7 minus 1, 7 minus 1. Basically, you do this. You go, you say 7 minus 1 divided by the width, the delta x. And since it was the delta x that changes a 1, 6 over 1 means there's going to be 6. That's how many trapezoids I'm going to have. And we finish that up. That would have been 1/2 B6 plus B7. But that's the hard ways to think of all those trapezoids. It's better to realize that you can put the whole area together and realize each one of these had the same half in front. So I can pull that half out. And if you look carefully, I got a B1 added to a B2. So B1 plus B2. And then I realized that the second trapezoid is B2 added to B3. So in other words, there's a repeat here of B2. That means there's 2 of the B2s. And then I added a B3 to that. Plus, then I do the next trapezoid, I realize, lo and behold, there's a B3 again. So you see, there's a duplicate of the B3, and then I added B4. So there's 2 of the B3s. Then you'll find out there's 2 of the B4s. Then there's 2 of the B5s. But there's only 1 of the B6s. So you have 1 B1s, you have 1 of the B6s. Where do I get those B's from? Where they touch the function f of this number 1 is that base. This one is f of 2. This one is f of 3. It's the functional value when x is, let's see, 1, 2, 3. This one is 3. Yeah, f of 3. It's the functional value. This one is f of 4, f of 5, f of 6, f of 7. So 1/2 f of 1 plus 2 f of 2s plus 2 f of 3s plus 2 f of 4s plus 2 f of 5s. And then we only had 1 f of 6 plus f of 6. And you just, my opinion, you plug the function into the calculator and let it do the work. Next page was a chart I mentioned to you. Why don't I give you a copy of all of that? Because we did most of them. We did the trapezoidal with, with 2 units long. Oh, this was the one we just did. Okay. We've done most of these. I think there's only one in here I didn't want to do no more. It was like a half unit of something. I didn't want to do it. I don't know. But let me get that picture for you. I'm going to post it for you. So I'll be right back. Okay. There they are. And you were supposed to try to think about what kind of approximations overall did I have. It's nice to look at it. It could be on the AP test where they actually ask you to, would the final answer be over or under? And you're looking at it. Well, we already knew we had a magic answer. We already knew that the answer was around 40, wasn't it? So we cheated. But if you didn't have the integration done, because what if I didn't give you a function? What if I just gave you values on a table or something? All right. Fill in your chart and double check. Please double check to see how close we were. The first person that tells me of any mistakes we had, they'll get some points. Next page. All right. Speaking of a table, just like this right here, we have a table. And I don't know how many I'm going to do here. We only have values from 0 to 25, and they're not even every value. It's some of the values. And we're going to approximate. If we had the full curve, we would know what the curve was doing. But you don't know what's happening between 0 and 4. All I know is at 0, I was at a height of 15. At 4, I'm at a height of 6. So I know it dropped. But who knows? Maybe at 2, it went up. It could have gone 0. Let me draw here. 0 goes up, then come back down. It could have been like up and then down. You don't know what happened in between. But since I only have these 2 places, I can only approximate the behavior as that line. You don't know what's happening between. It doesn't matter. We're going to use this table and approximate the area under the curve from 0 to 25. That means all the way from 0 to 25. That's this x and that x. Using midpoint sums with 3 subintervals. So I'm looking from how many pieces do I have? 1, 2, 3, 4, 5, 6, 7. And I have 7 pieces. Well, I've already used the beginning and the end. What's left? 1, 2, 3, 4, 5. How am I going to get 7 or 3 out of there? Well, look at this here. If they have to be the same, technically they don't have to be, but AP calculus does not require you to think about one interval is longer than the other. If I go from 0 to 7, so if I go here, that's an interval. If I go to here, that's another interval. And if I go from here, it's another interval. You can see that I could have created exactly like a midpoint would be between the 0 and the 7. So right here would be my midpoint. Right here is a midpoint. Right here is the x midpoint. It's as best as I'm going to get. Another way to look at it is I have that interval, and then the next interval overlaps, and then it overlaps. Let me erase all that so I can make it one more time. We're going from 0 to 25. So if I say this is a rectangle with the left endpoint, the right endpoint, and the midpoint. That means for the next rectangle, the right becomes the left, and it's going to go around those. That becomes the right of the second rectangle. And then the right becomes the left of the third rectangle. Left, right, and this was my left, and it was right there. So you can find the midpoints each time. Very simple, okay? So I want to approximate. So my area is approximately 3 rectangles. Length 1, width 1, length 2, width 2, length 3, width 3. So in this case, my first length, if we want midpoint, midpoint is going to be what the length is. My midpoint will be, remember, my length is the vertical, it's not writing. There's my length, my vertical distance. My width would be that distance here, that whole segment from here to here. So my length would be the f of 4, which is 6. I could write that out, f of 4 times the width. Well, the width is from 0 to 7, 7. My length of the second rectangle, look carefully, the length of my second has to be f of 12. That's where the midpoint goes. F of 12 times its length. 15 minus 7 is 8. 15 minus 7 is 8. Plus the length 3 comes from the third midpoint right here. F of 20 times the distance of this interval is 25 minus the 15, right? I can't read it. Need to erase it so I can see. Okay, 25 minus, so it's 15. Oh, come on. So you could just go to the table and say it is approximately a 6 times the 7 plus a negative 10 times the 8 plus the 8 times the 15. Oh, I'm sorry, it's not 15. It's a 10. Did anybody catch that? The 25 minus 15 is 10, not 15? Okay, 10. So that's 42 minus 80. And yes, there is negative areas. It's underneath the x-axis. Plus 80. So I would say my answer is approximately 42. Now, let's do it again. B. Left-handed Riemann sums with 4. How am I going to get 4? And I'm going from this time, look up here. I'm going only from 0 to 15. I'm only going from 0 to 15. That's called the indefinite integral. I know I'm starting at 0 and I'm going to 15. This one started at 0 and I went all the way to 25. 0 to 15. So I'm stopping here. So I need to say, how am I going to get 4 out of there? I don't know if I'm going to get 4 out of there. Does it say 4? From 0 to 15? 1, 2, 3. Yeah, here it goes. Watch this. This is 1. This is 2. See how overlap? You always have to overlap. The right becomes the left. And then it just gets kind of confusing here. This is my third. This one is my third. And last but not least, overlap that last piece. This is my fourth. It gets kind of confusing. I don't know how you want to look at it, but in my case, I can realize that this is my one interval. This is my second interval. So why don't I just do those two first? Area is approximately, and I'm doing the left. The first one, the left is 0. F of 0, that distance from 4 to 0 is 4. The next left, believe it or not, is the 4, f of 4. That distance here, 7 minus the 4 is a 3. My next one is this one right here. And I write all over my paper. I get kind of lost in my, there it is. Plus f of 7. 7 is my left. See, 7 is my left. 12 minus 7, 5. Last one, f of 12. 15 minus 12 is 3. And so my f of 0, let me do some cleaning up a bit here so I can see those values very clearly. And I know you guys are better than I am at artwork. F of 0 is 15. 15 times 4. F of 4 is 6. 6 times 3. That is a 3. F of 7. Remember, I'm only going up to the, how far was it going? It's only going to 15, wasn't it? Oh, I was only going to 15. So that's why I had 1, 2, 3. Yeah. Let me erase that other line. Oop. That line. Six and the 3. So now I'm doing f of 7, which is a negative 5 times a 5. And then f of 12, which was negative 10 times the 7. Is approximately 60 plus 12 minus 25 minus 70. That's approximately 72 minus 95. That answer would be a net of a negative 23. Another one. 4 to 20. Pay attention. 4 to 20. Right-handed. 4 starts there. 20 stops here. And I need to create, again, 4. So it looks to me like 1, 2, 3, 4. Every 2 makes an interval, and the left and the right, the left one is the right of the previous one. So it gets kind of confusing. So area will be approximately, I'm using the right now. So from 4 to 7, I need f of 7. F of 7 is a negative 5. The distance between 4 and 7 is 3. Plus, now the next one, that was 5 to 7. Now I'm at 7 to 12. So the right side is off the 12. That would be a negative 10. That distance between 7 and 12 is 5. Plus, now I've done now I got to go 12 to the 15. The right side's a 15. F of 15 is a negative 2. And between 12 and 15 is times a 3. Plus one more. That set of 2. The right side is the 20. F of 20 is a positive 8. And between 15 and 20 was 5. Negative 18. Negative 50. Negative 6 plus the 40. So, I don't know. Negative 68 and negative 74 plus 40. Negative 34, if I'm correct. And one more on this page. We're going from 0 to 25. Oh, that's the whole thing. Trapezoids. trapezoids. That means if I only want 3 of them. So let's see, how am I going to divide this up into 3 intervals? Let's see, that would be 1, 2. That's not enough. I need to go longer. Go 3. 3, 3, 3. That gives me 3. Is that what I wanted? Ah, perfect, perfect. Which implies base 1, base 2. You see that? And see base 3 and base 4. Left, right, left, right, left, right. Left, right, left, right, left, right. So I have all the bases. So area should be approximately, I'm going to do, are all the distances the same? They haven't been. So I'm not even going to pretend to know that they're the same. This is a 7 difference. This is a 8 difference. No, so I need to realize that the first trapezoid will be the distance between 0 and 7 is 7. 1/2 times the base, so that distance here is 7 halves times f of 0, which is 15, plus f of 7, which is a -5, plus, now from 7 to the 15, that distance was an 8. On the x-axis, that's the height of the trapezoid, if you were to lay it horizontally, is 8 over 2, and f of this base is -5 plus -2. One more, plus the distance between the 15 and the 25 is the 10. That's 10 over 2, h divided by 2. This base is a -2, plus this base is a 20. So I have 17 halves times 10 plus 4 times -7. I'm going fast, so there's a possibility that I'm wrong here. 5 times the 18. 170 over 2 minus 28 plus 90. You can finish that math. I don't know if I want to do it. Oof. Very AP style. So here's your day 53 homework. And you're going to do all of them. That's using a table. That's what we just got done doing. And I got to go to the doctor. So, again, talk to you later. Page. Those 2 pages. You only have 9 problems to do. Have fun with it. Have fun. Just